I'm going to ask DeepSeek, can you help me calculate the wheel and pinion sizes and number of teeth for a, let's just say, watch that I'm designing. Now this is super interesting. It tells you that it's thinking, and then it's telling you its process. So you'll have to slow this down if you want to actually read through this. Actually, let me change the screen size. Hopefully you can read that if you pause it. But I can't read as fast as it's writing. But basically right now what it's doing is thinking, and then it's going to give its answer. And all this is just to show its internal process, which is so freaking interesting. Wait a second, maybe I got the ratio backwards. If the fourth wheel makes 1 rotation per minute, I love it. It's going way down deep into a rabbit hole here. It's thinking about... It was talking about beats per hour, beats per minute. That's like... Now, one thing, I've already done this. I've played with this before, and I've had some problems with terminology. Like the minute wheel and the hour wheel, and the cannon pinion. Depending on the watch movement design, those wheels can have different names. So I've gone through this process before with DeepSeek, and this time I'm going to try to force it to find the correct terminology. I mean, to use the same terminology as I am, but it's really just gone down an incredible rabbit hole. It'll be really interesting to see what all that it's written was. Oh, so the thing is also, I have the George Daniels watchmaking book, and it has a lot of these formulas and things in it, and I'm kind of convinced that DeepSeek has trained on the book. But when I first bought the George Daniels book, I was like, this book is probably the only book that ever was written that contains this detailed information, just because I'd never been exposed to that kind of book before. But then after kind of, I don't know where I started seeing it, but other books, I realized that back in, a couple hundred years ago, that there were like many, many books written about this stuff. So because all those books are in the public domain, and they've probably all been scanned by Google, and then incorporated into OpenAI and other models that DeepSeek is supposedly a byproduct of. I think that there's a lot of literature actually about watchmaking from a technical point of view, and that literature is part of the training of these models. But this is absolutely crazy what it's doing right now. But anyway, what it'll do at the end of this process is it'll boil this down to a short answer. And then I'll go back to show you what the question I asked was, and we'll try to figure out why it went into this insane level of detail. I think because I wasn't specific enough in I just asked it if it could help me do that, and it's trying to. This approach isn't working. Perhaps more intermediate wheels are needed. Oh my God. I'm clearly missing something. Let me check a real world example. For example, the ETA, that was incredible. Holy crap. In the ETA 2824-2, the fourth wheel is actually the... Oh, this is cool. Actually, I wanted to check the all the wheels, like to better understand the gear ratios in all the wheels. I've been focused on the hour and minute because it's easy and I have to actually make those first. But it's doing all the math between the in the gear train down to the balance wheel. That's why it's doing all this. But it should have just answered this question. Sure, I can help you. Sorry, I have a bit of a cold here. Oh, so another thing about this is the online version of DeepSeek, and I downloaded a version that I ran on my Mac. There's like different versions that have different hardware requirements, and the online version is using a high version that requires a lot of hardware. If you download DeepSeek and run it on your locally on a Mac like this, it won't be able to answer in this depth, because I compared the same questions between the two versions, and the local version is much smaller, so it just kind of gets confused much faster. Not that it's not getting confused here, but again, I think it's because I asked it too general of a question. Now, the thing about this also is it will help you calculate the modulus of the gear teeth themselves with the backlash, like distance, so that here it goes. That's the answer. Okay, so to design the wheel and pinion sizes for your watch, follow these steps based on a balanced frequency of 4 Hertz, 28,800 beats per hour. That's probably taken from the 2824-2. And a typical 15-tooth escapement wheel. Gear train structure: mainspring barrel, center wheel, third wheel, fourth wheel, intermediate wheel, escape wheel. And the fourth wheel rotates once per minute. Third wheel, center wheel, once per hour. Just trying to visualize that, because the center wheel, it's confusing on 2824 because the center seconds. Anyway, intermediate gearing. Final recommendation for 4 Hertz balance: escape wheel 20, intermediate wheel 128, intermediate pinion 10 leaves, fourth pinion 8 leaves. Okay, so I think it got confused because the original question was, can you help me calculate the wheel and pinion sizes and number of teeth for a watch that I'm designing? Okay, it was too general. I didn't specify which wheels and pinions, so it focused on the train of wheels instead of what I really was going to ask it in a follow-up. Okay, let's just start with the fresh question. optimal sizes and numbers of teeth on the wheels and pinions if the offset between the center axis and the axis of the minute wheel is 12 millimeter. The reason I laugh is that I kind of know it can't do this because I've been through this before. I'm trying to be more specific than I have in the past because the general question really threw it for a loop there, but this level of specificity may also cause some problems. Okay. Can you help me design the cannon pinion, hour wheel, and minute wheel for a traditional watch movement? Specifically, the optimal sizes and numbers of teeth on the wheels and pinions if the offset between the center axis and the axis of the minute wheel is 12 millimeters. Oh, wait, does it keep my old ones? Oh, that's interesting. Okay, that's great. I didn't know it kept all this. That's really cool. So I think I'd like some help making a mechanical watch. Can you help me calculate the number of teeth on the minute and hour wheels? Let me just review this. Yeah, so this is cool. All right, so forget all that. It recorded my session before. So let's just look carefully at this because I've never even looked carefully at it. I'd like some help making a mechanical watch. Can you help me calculate the number of teeth on the minute and hour wheels? So it thought for a little over 2 minutes, and then it said, okay, so I need to figure out the number of teeth on the minute and hour wheels for a mechanical watch. Where do I start? Let me recall how gears work in watches. I know that in a watch movement, there are several gears that transmit power from the mainspring to the hands. The gear ratios are crucial for the correct timekeeping. The minute and hour hands are connected through a set of gears, right? The hour wheel must rotate once every 12 hours and the minute wheel once every hour. So the gear ratio between the minute and hour wheel should be 12:1. That's correct. That means for every full rotation of the minute wheel, the hour wheel turns 1/12 of a rotation. That's correct. But wait, gears aren't directly connected usually. There might be intermediate wheels, plural, called the cannon pinion, minute wheel, and hour wheel. That's correct. Now, here's what got confused. It understands that there's an intermediate wheel, but in terminology, the minute wheel is the intermediate wheel. In other words, the minute wheel, this is functioning like an intermediate wheel. So the cannon pinion is coming up like this and turning the minute hand. And then the cannon pinion goes to the minute wheel, and the minute wheel pinion turns the hour wheel. And so that's how the minute wheel is functionally an intermediate wheel, but it's not the intermediate wheel as some watches have a wheel called an intermediate wheel. In this standard design, it's called the minute wheel. So that's what gets confusing, I think, for it and also for me. But I'm starting to get, but if you imagine a kind of dumb search engine, large language model trying to figure this stuff out, when the terminology doesn't match, it gets confusing. Anyway, there might be intermediate wheels called the cannon pinion, minute wheel, and hour wheel. Let me visualize the typical layout. The cannon pinion is driven by the main gear train, which is connected to the escapement and balance wheel. The cannon pinion drives the minute wheel, which in turn drives the hour wheel. So the cannon pinion is attached to the center wheel, which rotates once per hour. The cannon pinion, it's attached, yeah, but it's attached through the cannon pinion is attached to the cannon pinion drives the minute wheel. So the cannon pinion is attached to the center wheel, which rotates once per hour. Center wheel. Okay, yeah. So this is where it gets confusing. It's talking about the center wheel on the traditional watch movement. It's not talking about the wheel in the center, which is the hour wheel at this point. The cannon pinion drives the minute wheel, which in turn drives the hour wheel. That is correct. Cannon pinion drives the minute wheel, which in turn drives the hour wheel. So the cannon pinion is attached to the cannon pinion also drives the minute wheel, which is a gear that meshes with the cannon pinion. Then the minute wheel has another gear that meshes with the hour wheel. Okay, that's all correct. Wait, maybe the cannon pinion is the one that's directly connected to the minute hand. That's correct too. So the cannon pinion rotates once per hour, and the minute wheel is part of the motion work that transfers the motion to the hour hand. Let me check. The cannon pinion is usually a friction fit on the center wheel arbor, which does rotate once per hour. Then the cannon pinion drives a wheel, sometimes called the intermediate wheel, and that minute wheel drives the hour wheel. See, it's figuring it out. It is an intermediate wheel from a technical point of view, but it's also called the minute wheel. The hour wheel is mounted on a tube that allows it to rotate freely, driven by this gear train. That is all totally correct. So the ratio between the cannon pinion and the minute wheel, and then from the minute wheel to the hour wheel must result in an overall 12-to-1 reduction from the cannon pinion, which is rotating once per hour, to the hour wheel, which needs to rotate once every 12 hours. Therefore, so it's reviewing everything. See, it came up with that very quickly, and then it's just reviewing it all again. But how does that translate to the number of teeth? Let's denote the number of teeth on the cannon pinion as C, the minute wheel is M, and the hour wheel is H. Cannon, minute, hour. Wait, but typically gears are arranged so that the cannon pinion drives the minute wheel, which then drives another pinion attached to the hour wheel. So perhaps the cannon pinion, C teeth, meshes with the minute wheel, M teeth, and then the minute wheel has a pinion, let's say P teeth, that meshes with the hour wheel, H teeth. In that case, the gear ratio from the cannon pinion to the minute wheel is M over C, but since the cannon pinion is driving the minute wheel, the rotation speed of the minute wheel would be C over M times the cannon pinion's speed. Then the minute wheel's pinion P teeth drives the hour wheel H teeth, so the rotation speed of the hour wheel would be PH times the minute wheel's speed. Therefore, the overall ratio from cannon pinion to hour wheel would be C over M times P over H. Since the cannon pinion rotates once per hour and the hour wheel needs to rotate once every 12 hours, the ratio should be 1 over 12, therefore C over M times P over H equals 1 over 12. But in watchmaking, there are standard numbers of teeth used for these wheels and pinions. The cannon pinion often has 10 or 12 teeth, that's correct, for example, sometimes 8. The minute wheel and hour wheel might have more teeth. Also, the pinion on the minute wheel, the one that drives the hour wheel, typically has 8 or 10 teeth. Let me try plugging in some standard numbers. Suppose that the cannon pinion has 10 teeth, C equals 10. The minute wheel is driven by the cannon pinion. Let's say the minute wheel has 30 teeth, M equals 30. Then the ratio from the cannon pinion to the minute wheel is 10 over 30 equals 1 over 3. So the minute wheel would rotate once every 3 hours, but the minute wheel is just an intermediate gear. It's not directly connected to the minute hand. Wait, actually the minute hand is connected to the cannon pinion via the center wheel. Wait, maybe I'm confusing the terminology. This is crazy. Wait, perhaps the cannon pinion is part of the motion works. This weight thing is weird because it sounds so human, but it's kind of just repeating. Anyway, it's crazy. The center wheel usually. See, it's kind of repeating the mainspring. Perhaps the cannon pinion is a pinion, the small gear that meshes with the minute wheel. Yeah, that's correct. Therefore, blah, 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 blah. So it's getting to the same thing again. C over M times P over H equals 1 over 12. So the product of the two gear ratios is 1 over 12. That's correct. Now it goes through this whole thing again. And then it talks about teeth, blah, blah, blah. So I don't know if you know where this is going, but I know where it's going. So it's just working out over and over again different kind of approaches to this thing of calculating examples of ratios for this. So you can have cannon pinion has 12 teeth, minute has 48. Minute pinion, I think, is what P is, has 8, and then the hour hand has 32. Common values are 10, 30, 10, 40. Another example is 12, 48, 832. Then 12 over 48 times 8 over 32 equals 0.25 times 0.25 equals 0.65, not 1/16. No, equals 1/16, not 1/12. Okay, so here it's figuring out that this ratio is wrong. Wait, so 12 over 36 times 8 over 32 equals blah, blah, blah. 1 equals 12. Okay, so here you have a good ratio that is worked out. So just in case you're not clear, like this would be the gear ratio here. This one needs, between this pinion and this wheel, you need either 3 or 4. And between this pinion and this wheel, you need whichever one you didn't have here. So if this is 3, this should be 4. So there are multiple solutions. Choice depends on practical consideration, like the blah, blah, blah. Okay, now remember, in this one, I didn't ask it the size yet. So I'm just trying to get it to figure out the 12-to-1 gear reduction and make a recommendation. So it figures out this whole formula, which it's interesting because it kind of could have just... No, here's the way to look at this, I think. This is the answer that it gave. Final answer, for standard configurations, use a minute wheel with 30, hour wheel with 40, Canon pinion of 10 teeth, and minute pinion of 10 teeth. Adjust values if using different starting teeth. Example, 1236, 832. Okay, so the thing is, in theory, it could just go to the book, like a book, and just copy this information. But what's fascinating about it is it doesn't do that. It actually goes through this process. And that is what's crazy. So, and it comes up with the right answer. So now I say, can you draw an image to illustrate that? Okay, the user wants to build a mechanical watch and needs help calculating the teeth for the minute and hour wheels. I provided the calculations and examples, but now they're asking for an image. Since I can't actually draw images, I need to figure out the best way to help them visualize their gear setup, the gear setup. First, I should recall the previous explanation, blah, blah, blah. Maybe I can describe a simple diagram using ASCII art. That's like, you'll see, ASCII art is this. Let's think about how gears mesh. The Canon pinion C meshes with the minute wheel M, which is larger. Then the minute pinion P attached to the same arbor as M meshes with the hour wheel H. So there's a 2-stage gear train, correct. I should represent each gear with circles and label the teeth numbers. Arrows can show the rotation direction. Also, indicating the rotations per hour would clarify the speed reduction. Let me sketch this out step by step. First, draw C and M meshing, then P and H. Ensure the ratios are correct. C over M equals 10 over 30, P over H equals 10 over 40. I need to check if the ASCII will be clear. Use hyphens and slashes for the gears maybe. Label each part. Also mention that the minute wheel and pinion are on the same shaft. That's important for understanding the gear train. Wait, the user might not be familiar with gear terminology. Should I define Canon pinion, minute wheel, etc.? But in the previous message, they already got the explanation. Maybe a brief reminder in the diagram description would help. That is insane. Also, maybe suggest that they can use software like CAD for a precise drawing. But since they asked for an image, the ASCII should suffice for conceptual understanding. All right, let's put it all together in ASCII with the labels and ratios. And then it answers, I can't directly create images, but I can describe a simple ASCII diagram to visualize the gear train. Here's how the gears interact. Canon pinion, minute hand, hour hand. Now this is, I feel like it's not lined up correctly, but basically, oh yeah, maybe I've squeezed this too much. Where'd that go now? That's interesting. So I got to view this. I think it doesn't understand the width of the window. Let's try copying this into a text file. There's like a soft wrap happening there. Yeah. See, this part shouldn't be there. It should be over there. But then Yeah, so it answered it correctly here. See, there's a little bit of misalignment. Like this should probably be. It doesn't know the width of these characters depending on the font, but basically this is correct. Yeah, so it's still not perfect because it's trying to draw this stuff in, ASCII art. But anyway, let's see. Keynotes. Canon pinion drives a minute wheel. Minute wheel, blah, blah, blah. Okay. So I had said, sorry, but I don't understand that image. Can you try again and focus on how the gears are stacked? Okay, so I want to switch threads here because I did this twice before. So this is back to the kind of refined question. Can you help me design the Canon pinion, hour wheel, and minute wheel for a traditional watch movement, specifically the optimal sizes and numbers of teeth on the wheels and pinions if the offset between the center axis and the axis of the minute wheel is 12 millimeters? I probably should have told it to not worry about the train of wheels because it's probably going to go into that whole train of wheels thing again. You can use this blueprint to draft a technical drawing in CAD. This is freaking cool. Now, this is like, I'm going to have to use this. This is incredible. Because all I have to do is measure the distance between those two wheels and then it'll give me everything. That's insane. There's one other thing I wanted to check. I'd like to, come on. Oh, no, that's going to, I just hit return after typing the word I. Not good. It'll probably give me back like the history of the universe. I. Well, that's a complex question. Or is it a question? Is it a statement? Is it the ultimate identity function? Do you have any idea what you've asked me? This is going to be hilarious. It's going to tell me that it ran out of, the server's busy though. It seems like there's a small hiccup in your message. That's correct. Wow. Okay. So, can you output this entire chat in HTML so I can print it? Please use the color red to highlight my questions, green to highlight your thoughts, and blue to highlight your answers. Thank you. So you can see here when it redrew it, it tried to simplify it. Yeah, it said if you'd like me to clarify, let me know. For example, here's a simplified diagram. Now this HTML thing, the reason I do that is because you can't actually, at least with my Mac, if I try to just save it as a PDF, just based on the way it's in the browser, it just gives me what's on the screen. A lot of web pages will give you the frame, but I don't have like a print frame, print page. Oh, this web archive should work. Oh, I forgot to send this. Jeez. Weird. Okay. So here, this is interesting. Okay, the user wants the entire chat converted into HTML with specific colors for different parts. Red for the question, green for my thoughts, and blue for my answers. Let me start by recalling the conversation history. First, I need to make sure I can capture all the messages correctly. The user initially asked about designing watch components. I need to structure the HTML properly. The user mentioned using colors. In their example, blah, blah, blah. Okay, so it's still going. Okay, here we go. Now this is great. How to use: copy the code above into a text editor, save it as watchchat.html, open it in a browser. That's insane, right? Copy. Okay, and then I should be able to open this with Firefox. So it didn't give me the ASCII art, but I think I can ask it to do that actually. But what happens if you hit run HTML? Okay, that's a quicker way to visualize it. I should have asked for it in a certain color. Okay, I'm going to give up on that. So that's DeepSeek. That is pretty wild. Thanks, that was super interesting chatting with you. Best of luck going forward. Okay, the user just thanked me and wished me luck. I need to respond warmly and acknowledge their kind words. They were working on a mechanical watch design, so maybe highlight that aspect to make it personal. Also, offer further help in case they have more questions later. Let me start with a friendly emoji to set a positive tone. Mention the watch project specifically to show I remember and value our conversation. Encourage them to reach out again, maybe add another emoji to keep it light. Keep it concise but sincere. Avoid any technical jargon now since the conversation is wrapping up. Make sure the grammar is correct and the message flows naturally. All right, let's put it all together. Thank you so much. It was a pleasure diving into the intricacies of watch mechanics with you. Your project sounds fascinating. If you ever need help with gear ratios, tolerances, or anything else, horology related or beyond, feel free to reach out. Best of luck with your watch design and have an amazing day. That is freaking crazy. Thanks for watching.